Hi everybody, here is the video here for chapter 5. And as I got into this chapter, I realized, well, really it didn't need to be two separate sets of video and lecture notes and all that, so that's all one lecture for all parts here 5 uh, throughout on the collection ADT. So a little bit of housekeeping. Um, we kind of talked about, or I put on the syllabus, a test after sections 4 and 5 because we did 1, 2, and 3 on the first. And we did 4, and if you got it, we're finished there. I'm going to post a homework assignment for you on 4 within the next day or so. Probably this Sunday night I'm making it, so I'll put it up for you tomorrow night and Monday night. But the more I'm kind of looking at it, we've got 2 more topics to cover, not in the book, but about 2 weeks on each of them. And so I've been thinking, well, we could do a second test here on 4 and 5, and yeah, that would work, but I'm thinking really, since we did the first test a week or so later than normal or planned, that I'm really going to not do a second test, but we'll do the final with on chapters 4 and 5 out of the book, the 2 sets of supplemental material on N and NP, I think it is. And that way then, knowing how much y'all have got on your plates otherwise, uh, maybe a little less time to have to worry about studying for another test. It would mean that the final would really be a regular chapter type test with not a lot of comprehensive material. I imagine it'd probably be just like the first test of about 20 questions, 5 points apiece. I say most of it would be on 4 or 5. These other 2 areas probably going to be a couple of tied together type questions. There since it's a final exam, but that's really where I'm leaning right now. And so I really want y'all to do a little thinking. Look at your schedules here. We've got 4 weeks of class left, 2 major topics here after chapter 5. So I'm trying to say, okay, what would be the easiest for y'all, create the least stress, things like that. Certainly with how well all of y'all did on homework and uh, first test type of deal. I expect the same thing. We'll do a homework assignment on 4 and on 5 type of deal. Not sure about the other material. I've got to get it from Dr. Watson and from Philip Kilgore uh, type of deal. It's an area I don't know much about. So we'll look and see if there's any type of assignment with it to work with. We'll just see what happens there. But as I say, that's right now kind of what I'm thinking is we'll do a final. It'll be just like the regular test. I'll put out a study guide for it a week, few days before, whatever, then post it. And then give you a chance, several days to answer it, just as you did the fine job on test 1. And hopefully that'll make it easier for y'all and reduce some stress from this class as you're working on your others. Um, one other housekeeping matter is if you're on campus this Friday, which is the 8th, you're going to notice maybe some of the parking near our building blocked off. You'll notice a lot of folks wandering around in suits and dressed nice and all that. The LSU Board of Supervisors is having their monthly meeting up at LSUS, and this is only the second time I know of in a good many years. They came like 3 or 4 years ago, pre-COVID, and that I think was the first time they'd met on campus. I think I heard from Chancellor Clark in about 10 years. So, as I say, if you see some people, particularly over in the UC, they're going to meet up in the UC ballroom. So, if you're over in the University Center on Friday, uh, expect to see some folks you don't recognize. I'm sure that they will be going through the collaboratory down on the first floor of our building. They won't be sticking probably in classes, anything like that. But as I say, don't be surprised if you don't see some folks, and especially a lot of them on the Board of Supervisors will have an LSU pin on their lapel. You'll have also the chancellors, presidents from the other LSU system, schools, med school, Baton Rouge, Alexandria, probably Eunice. So expect on Friday there to be a lot of extra people on campus. So if you're on campus, allow some extra parking, particularly if you park over on our side. They'll have, I'm sure, the horseshoe, double lot blocked off for them and others areas too. So, but as I say, if somebody with an LSU pin on their lapel on Friday asks you about the program and your experiences just as you're walking the hall or whatever, tell them hopefully that you've had great experiences here and all of those things. But the good thing about having the Board of Supervisors here is, um, it's a lot of times it's a matter of support and how much support we can get from the Baton Rouge main campus, the Board of Supervisors, things like that. There's certainly some things in the legislature maybe going on from some friends, Senator Bear Peacock, and our lifelong friends. And he called me a couple of weeks ago with a couple of questions about things. And so, as I say, I talked to Dr. Watson about it the other day and said, hey, I had this phone call and just kind of wanted to, let you know that, if you hear something in a dean's meeting about changes or how we are governed or otherwise, you never know what's going to come out of the state legislature. And so, if somebody suddenly says, well, they hear this is coming on or this is going on or whatever, um, the Louisiana legislature raises a lot of things up the flagpole and see who shoots at it or what it comes down afterwards and how it gets changed. So, if I hear anything, um, I certainly pass it on to my students. If even after, this semester is over and, I don't get a chance to hear from y'all or whatever, if you've ever got a question, um, for me about LSUS or things like that, what's going on, as I tell my 115s, folks, if you ever need a letter of reference or recommendation for scholarship, graduate school, whatever, I normally write 3 or 4 a semester. I think I've already written about that many this semester. I keep all your grades kind of on my spreadsheets I've got here on the computer going back over 30 years, even on the old DOS machine. I still keep it running because I've got student grades going back for, that many years on it. Uh, so if you ever have a question about anything at LSUS, if you, whether before you graduate or after graduate, ever need a letter, I mean, I had a student who, biology major, who graduated, stayed in touch, and she applied to Baylor College of Medicine for a PhD program. And I wrote a letter for her about that program. Now she switched up here to the LSU Med School, and we'll start here in, I guess, the fall in the medical degree program. So if y'all ever need me, it's always a pleasure. As y'all know, I did I've kind of mentioned a little bit with the different hats I wear, whether it's LSUS, whether it's my audio video installation design company, my volunteer work at First Methodist as audio director. I did a wedding sound for a wedding this weekend. And one of the groomsmen came up to me and he looked for a second. He said, "Do you teach at LSUS?" I said, "Yes, I'm Claiborne Sharp." He said, "I had you for computer science 20 years ago. Still remember some of the things we talked about and use them." He's now selling technical items type deal. So, who knows? Even though we haven't done a lot of meeting face to face, whether it's if I see you on campus, whether I see you off campus or otherwise, any way I can help y'all in the future, it's always an honor and a pleasure. So keep my phone numbers, keep my emails, all of that. And but wanted to kind of tell y'all a little bit about the Board of Supervisors meeting here at the end of this week, thinking about what we want to do on the final. If y'all would prefer that we go on and split this into two, where we do a chapter 4 and 5 test and final with here on the new material somewhat, maybe a little bit more comprehensive stuff on the final. Whatever y'all want to do is fine with me. So email me, talk amongst yourselves as you see each other in your other classes, whatever. And I want to do for y'all what A, reduces your stress level, and B, ensures that all of y'all make the very highest grade possible in this class, just like you're doing now. And I've bragged on Dr. Watson to several others about how well y'all are doing and nice job on the homework. Um, if you haven't swung by the departmental office yet to pick up your test and homework, there, test one, homework otherwise, make sure you do too from Mallory or Sierra. Um, so, anyway, well, let's get here into chapter 5. As I say, it's actually a little bit shorter chapter dealing here with collections, alternative data type. And it basically, the collection ADT allows us to store and retrieve information based on its value, not when it was stored, like with a stack or a queue. And so you're really looking here at how we implement databases, direct access files, all of those things. And so you've got to consider as you're searching here for the information, the equals method that only considers two objects are equal if they're aliases of each other, looks at the contents, not the memory addresses. Collections here initially allow duplicates and can find any one of the elements, no distinctions. Uh, you can't have null elements. It talks about minimal preconditions for operations. Uh, do need to check when you're adding to a full collection. If make sure if you can't add to a collection, particularly if it's as an array, don't have that problem with a linked list, or if you're removing from an empty collections. But as the other chapters have said, our collections in these cases are generic, and the client defines what type of data it's going to hold. So it starts off here on page 300 just with a little simple code talking about the collections package, and it implements a collection of type T. Let's say allows for additions, removal, access of the elements. Null elements are not allowed, duplicates are. And we're going to talk about duplicates when we get to the very last part of the last section. I think it's section 5.7, where we talk a little bit about set theory type of deal. So you have this first code here at the very end of section 5.1 that just defines a collection and all that. And then we get into section 5.2 of saying, well, if it's an array-based collection, and as I say, we're looking here initially in 5.2 about non-sorted. 5.5, we'll look at sorted. And so it talks about how we have an array from 0 to however many elements. We have to keep track of the last location. When it adds an element, it adds it to the back normally, and so you're dealing with that. If you remove, then what it does when you remove an element, it just moves what is the last element into that space. So but it's still unsorted and all of those things. So they talk here about you got country abbreviations, and you've added Colombia, I think it is, COL, and one of the second element added was Mexico. You pull Mexico out, and Colombia leaps forward several spots and fills in location 2, sub 1, where Mexico was. So you can do that. So I say the code there on 302, 303 is very straightforward here on the array collection.java. As I say, moves the former last element to the position that was element was removed from. As I say, it's unsorted, and if it was sorted, then you'd have to have a loop to move everything down one position from, if you remove the third element, then you'd move the fourth to the third, the fifth to the fourth, so on and so forth. So a little bit of simple code there on just creates a collection and then allows for the dealing with capacity on it, but pretty well straightforward here for the code here on page 302, and I've got here in the lecture, made a couple of notes, but not much on it. So just kind of be aware of those things. And so then they start applying this idea of this array in section 5.3 to vocabulary density. And so they describe the idea of this example, that they keep track of the number of different words in each of the words, and not how many times a word appears, but just how many different words within the total number of words of the document. And so they say that linguists look at this score where they divide the total words by the number of different words, and it comes up with this score and on how dense, whether the type of words are, number of words, this vocabulary density, and basically it's how many different words there are, and you say, okay, well, if I've got this density, then it's how many words are between where I find another word that I've got in the program, in the count. And so the lower the score, it says, then the simpler the case is. If it's a high score, then they say it's more complex type of deal. And here in the code, let's say the smaller number is more complex. As complexity goes up, then supposedly it's easier to read type of deal. And they talk here a little bit about, well, assuming the two texts are about similar in length, similar number of words in them. So you're going to read in this test file off of it and set the maximum different words. As I say, if you exceed that, they use like 1,000 for the example, then it would print out an error message that there were like at least 1,000 unique words, but you can't display the density of it. And it uses a couple of functions some of y'all might be familiar with that uses two lowercase that converts all caps to lower. It also treats if the word has an apostrophe in it, then that's valid type of deal. But as I say, just kind of where it's going through, it's doing this search here of this array, And then it says, okay, well, I'm going to read in this file. And then as long as it keeps finding words, then it takes each word and it says, if not, remember the exclamation mark, contains word, then word subadds word type of deal there. So you have that idea of just saying, okay, if the word's not there, then put it in there and then goes out, and at the very end, after it finishes, it prints out the number of words, the file name, the total words in it, and what the density score is, and all that. So kind of an interesting little program there, but purely just goes through there with a while has next. If there are more words to process, a simple couple of if statements there on the middle of 306, and there you are. So 5.4 gets into comparing objects. It kind of revisits a little bit of what we talked about earlier, where if an object has a equal value, then is it a value, or do you have pointers to the same item? And a little bit of discussion there using integer A and integer B, where that since they're both 10, then it says that's a true expression. They have a couple of circles which are of the same radius. They say they're equal. But if they're false, even though they're the same. But if they point to the same item, then that evaluates the true. So they use an example here where you build a database, kinda, of famous people. And you initialize it with the first and last names, the date of birth, and then a string, which is the facts about that particular person, in computer science in this case. And so they initialized it, then the user gives a name, then the program searches for the name and either displays a message that, here's the information on this person, or it's no information available. So, as I say, it's under the CH05 apps folder. So it goes through, it does input, output, it imports the collection framework, and brings in the file called support famous person. And that famous person then gets the information from the file, puts it into those four variables, first name, last name. I'm shuffling a paper here real quick because I want to make sure I highlight something for you. There it is. So, as I say, it reads in the famous, it's got a text file, .txt, and looks for delimiters or commas. And so it does string first name, last name, fact, integer, year, reads it in the file, puts it in the collection, and then it asks the user to give a value. There, the user gives a first name and then a last name. When they finish, then it will go through and they give an X, which means to stop. And so if they enter in the X, then or stop, then it will go out and quit adding values and interacts getting names and displaying information. So they add together this variable called person, which is a combination of first name, last name. If it contains the person, then it will retrieve the information and print out their information on the file. But as I say, basically a little simple program there talking about collections. It's kind of interesting how they talk about comparing here on these string values, these objects. As say, the people they pull up here on the program for their famous people, they have a couple of them you should be familiar with, both Countess Ada Lovelace Byron, there on page 313. Of course, she was regarded as the first programmer, worked with Charles Babbage and his son there back in the early 1800s on the difference in analytical engines. And of course, she was related somehow to Lord Byron, the poet. And you notice there her first name, Ada. And if you've studied any programming languages way back in the 80s, the Department of Defense wanted a common language for everything they had, and they put it out to public bid. It was called Ada. I remember studying it when I took programming languages. It was a weird language and all of that, so never really caught on, waste of our money and taxes. Another person, of course, they give here is Edgar Dertzka, and some of y'all have studied about him. But back in 1972, he won the Turing Award. But I think it was in 1968 he wrote a op-ed or letter or whatever to the Communications, the main publication of ACM. We mentioned it, where he really said avoid the go-to statement. It leads to sloppy programming. So a lot of the ideas that you've learned in proper programming, things like that, really, as I say, go back to some of his work there way back in the late 60s, early 70s on proper programming. But as I say, need to look at values that are either equal but also less than or greater than, returns the type of data it is. Talks here a little bit about, well, if it's less than, it returns a negative integer. If it's equal, returns a zero. Or if it's positive, if it's greater than. And they talk a little bit here, 314, 315, about natural order. And that's always good to keep in mind for either ascending or descending. It talks that some things are kept in order of lowest to highest, bowling scores, where other things, you want a low bowling score, a high bowling score. Other things, like in golf, you want to have the lowest. So you got to look at the natural order. And so it talks a little bit here on the idea on the famous person. Okay, you've entered a last name, a first name, and then came back in, and if they match, then it returns back the date of birth and the fact about them. But here they're just talking, well, the first thing you look for, if the last name equals the last name, then go through and compare, type of deal. And otherwise, it looks as first name compares to first name. So if the last name enters, then you compare first name. So let's say just kind of a little interesting interface. We get to 5.5. Let's say on sorted base and sorted array base collection. Say this one, we start really thinking about how to handle some things. Say we set up an array which is kept as a sorted item. So if you have it as a sorted item, remember then you can use a binary search or whatever to be able to find what you're looking for. So, add's going to take a little bit more time because, you've got to find exactly and move things down from where that's added. If you're adding at the 50th element, you've got 80. Well, you've got to move 51 all the way through to become 81. And but also, if you're searching here and it's sorted, then you use our binary search algorithm where you divide in half and half and half and half. And so you don't be like a unsorted where no matter what, or a linked list. You got to go from the first element to the whateverth element because you've got to look at everything. So once we know where an item is, then get and remove are faster. And so, as I say, this is what's stressed throughout here in all these sections on, there's certainly trade-offs. We'll get into in a page or two a little bit more about that, on some trade-offs. But as I say, it talks a little bit about enlarging the collection if we run out of space, or make sure that we're adding compatible types to what's in the collection presently, and a little bit of review of programming by contract, and we certainly talked about that. So, the implementation is a unbounded array. It uses a recursive binary search method. Talks a little bit about casting elements as comparable. And then as they add, must locate the spot to add it. If not, then the array, then we now have a location to add it in. And let's say then it'll shift everything to the right. Remove works about the same way. After found, shifts everything back down. And then we get back into here a little bit on 319. Some more discussion of copying by either reference or by copy. And really some good things here in this section here, 319, 320, things like that, all the way over to 323, on what happens if you have a set of data and, well, you copy it, and it talks here about the clone method. And the clone gets the value back. It provides for a strong information hiding type of deal. And whereas reference, the abstract data type manipulates the actual elements passed to it, allows for direct manipulation. Let's say it uses less time and space to copy or clone. As I say, it gets into some real good discussion here on 321, 322 on what happens if we change an element. But if we change the element directly, in some ways, then our pointers are off, our sorts are off, things like that. So it goes back into a discussion of, how do you do it? So they have here on 322 on the left side, they have three people and they're different weights. Doug at 230, Jane at 120, and Jen at 127. Then it sorts it. So then Jane is in the first position, Jen is in the second, Doug is in the third. But if Doug loses 105 pounds and he drops, but Doug is not resorted there where he's in the middle, then the sort's not updated. So it's a real good discussion here on both of them, whether it's by copy or by reference. The programmer has to go back and update the order to reflect the change. And here on the copy, Doug element is changed, but not the copy. Thus, the sort is wrong and it needs to be updated and resorted the right side by reference. As I say, new pointers from the element to the data. Somewhat same problem, deals with the actual value. Since the collection order is not updated, the collection is corrupted and needs to be restored. So that's one of those things, and I say it's a good way here they talk about here on 322, or otherwise if you are keeping some form of sorted list and you add something to it, or delete, same idea, then you need to go through and resort it. for many, many years to print out mailing labels on checks I write, personal, company, things like that. I've maintained, and don't throw any rocks at me, a program I wrote in BASIC back 30 some years ago. It still works. It's simple. You know, if I need to print out a bunch of mailing labels for mailing checks, believe it or not, a lot of my vendors still want a check, then, I have mailing label, just put the check in the envelope, slap the mailing label on it, I'm done. Well, if an address moves, somebody gets bought out or otherwise, then I have to go into this, and I wrote a little simple basic program, probably 40 lines, maybe. I don't know. But if I add somebody to the list, then I have a option. It says, do you want to resort by company name? So I can say yes, whether I've added or removed type of deal. Then it uses the sort function there that's built into BASIC, part of DOS. But as I say, do I want to resort? So that's one of those things you've got to keep in your mind, is if you're sorting on some criteria and you change the data, and then you've got to resort it in whatever way you're using it. So they look a little bit here, relook at this application of the vocabulary density, and they compare, okay, well, what if we have it sorted? And that's here on the top of 324. They say, what if we compare it as a collection or as a unsorted? As a sorted collection, comparing unsorted there in the fifth column versus sorted. And if you look at that, you notice that in most cases, after you get above, here 140 words, they get to some of them that have like 30,000 words, Shakespeare's Hamlet. Notice the sorted takes half the time of the collection, the unsorted, and it ranges all the way up to this combined file called mashup, where to sort it and count the number of unique words and all of those things. I shouldn't say sort, but count all the unique words. There, if it's unsorted, it took 10 hours, where if it was sorted, it took 7 minutes. So certainly, got to look at efficiency type of deal and all of those things. So we get into 5.6 on the link-based collection. Very much like our previous linked list, you have a node and a link to the next element. You add by declaring a new node, setting an item pointer to it, and update the count and set the rear address to the new node. It talks a little bit about finding, where maybe if we're going to find something, then if we're doing an array, then a while loop until it's found or it reaches a number of elements. Where if it's link based and you keep searching from font, keep going using your pointers, and then if it finds, it returns the value. If it's not previous, then it sets to the current location. And of course, if you remove under the linked list, you just remove the node that it was found from and take the pointer from the node before and point it to the big node that followed the one you removed. So, you've got to always keep track of those things. And so then we get over here to 353, not 352, 329 and 332, table 5.2. I don't know where that came from. And it's basically talking about, and it goes back to where we talked about in page 53. Looking at the time it takes, whether it's 0 to the 1, 0 to the n, linear time, 0 to the log 2 of base n, logarithmic time, where it depends upon the amount of time, the size of the problem. And it basically says, hey, it reinforces what we've talked about, that different ways of doing it have different advantages and different disadvantages. And as I say, you got to think about, well, the linked list will have more memory than an array, but it along with a unsorted array will take more time to get for both, since you have to go from the very beginning of the unsorted array and from the linked list to find the element that you want to find. So it's like anything else. We're looking at efficiency, whether it's time, whether it's the amount of memory. Linked lists, as we've talked about throughout, take up more memory space because you have the element and you have the pointer either to the element before, possibly, but definitely to the element following it. But memory's cheap, so, programmer time's a lot more costly, so you got to think about those things. We get to section 5.7 on collection variations. And a lot of it's just a review of the different types of variations of data. It says this collection interface that's found in the Java utility package supports 11 sub-interfaces and has 33 implementing classes. And there are 15 abstract methods within the interface. That's a lot to say grace over. So, it says collections interface is the root of the inheritance tree of interfaces. So just kind of reinforces the complexity of Java, and it does a lot of things, but it also has got good bit of overhead at times. So there are other methods from the collection interface. It talks here about other definitions. It talks about a thing called toArray, which returns the array containing all elements of the collection. It talks about a thing called clear that removes elements, or equals, which takes an collection argument and compares it to the current collection type of deal. It's got one called add all that takes a collection argument, adds it to the current collection, returns a Boolean value if it can be added or not, or retain all that takes a collection value and removes any element from the current collection that's not in the argument, or remove all that removes any elements from the current collection that they're also in the argument collection. Biggest thing here is on 331 to me is to remember that there are a whole lot of different ways to do something. And even if this was a normal in-person class and you were writing a partial program or whatever for the class, then, I've always done back when I taught programming, is I'd have a closed book portion of the concepts. And then when I gave the students a program or sub-program or whatever to write, a partial program, then that they could use their books or other things for. So certainly when you're out writing a program, whether it's in Java, Python, or whatever, the most current languages, C++, C#, who knows, you're not going to write a program normally secluded and all that. And so, you're going to keep in mind, okay, Java has all of these different sub interfaces. If you're using Java, the implementing classes, you're writing a program, you're going to have your reference books there at your desk or on file on your computer, whatever. So I don't worry about having students memorize code or how to write code, because you're not going to write code when you're out making all that money and hopefully endowing a scholarship for us. You're not going to be writing it without having references. So, just kind of be aware of it. It finishes up here at the last of chapter 5, here on 332, 333, talking about this bag abstract data type. It says basically you've got a bag of marbles. And you can do various things with this bag abstract data type. You can have duplicates, you can add marbles to it, you can look to see if the bag contains a given color marble, you can remove a specific item, you can look at how many elements are in it, or is it full, or is it empty. It's saying you could count all the types of one color, you could remove all the types of a certain type. And so it's got these basic operations here on the bottom of 332, 333. It's also, as I say, in the collection subdirectory of chapter 5. So basically it says, if the bag is not empty, return and remove some random element of the bag. Otherwise, if count all the elements in the collection that equal that target, or removes all elements that equal a target, maybe you're going to take all the blue marbles out or whatever. Or it says, you clear the bag where it contains 0 elements, so that's all good. And there are, of course, various statements about people not wanting things in the audio industry. Some of y'all have heard about how temperamental some singers, musicians are, and whenever a music act rents a space, Strand, Municipal Auditorium, whatever, and they put out this rider of, with what the sound system needs to be, the things for the musicians, they want a meal before, it's this, and they want water, and how big then the dressing rooms, for how many dressing rooms. Well, there's a famous story about some famous rock musician years ago who said, I want a bowl of M&Ms, but I don't want green M&Ms. And so they actually had to empty several bags of M&Ms into this bowl to have in that person's dressing room and remove all of the green ones. So that's an example here of this bag abstract data type. Now, it's also said in the industry that really wasn't a preference of that person, but it was to see if somebody read the fine print in the rider and contract to remove the green M&Ms. So you have these operations here on removing elements from this bag of whatever. And so you've got operations there that will remove and return a random element or count something, things like that. Removes everything. So you got the code here called bag interface. But the last thing it talks about on 333 and 334 with a couple of programs are dealing with sets. And it says here on the set, set ADT allows for only distinct objects, no duplicates. Most operations would work the same. Would have to check this first to see if the element's in the collection. If not, then adds and returns true. And they say, well, we don't have to reinvent the wheel. We could use our linked collection code. But since you can only add an item if it's not already in the data set, in the collection, then they rework the add, and you notice there on 334, there's about halfway down you see an @ symbol override, and then public boolean add t subelement. So that is saying to override the standard add function and allow it to be added only if it's not found. So then you have an if statement. If not this contains the element, then it adds the element by overimposing it and then returns true. So there's some talks a little bit here on 334 about how that can lead to some sloppy programming later on, maintenance issues, whatever. So they rework it here as basic set 2, where it adds some extra code to it. but hopefully will save headaches and maintenance issues in the future. And that is certainly true because we always want to make sure when we write a program from scratch that we think about that program's going to have maintenance, it's going to have updates, all of those things later on to it. And if we do a good job of writing the program initially, then it certainly will make it easier for those programmers who follow us later on to be able to do updates, maintenance, things like that. And that's very important because, as we've well discussed, a lot of programs have a very long lifespan. And so that's really everything here on Chapter 5. Let's say I'll post the homework probably there on Monday night out of Chapter 4. It's going to be only about 6 things, exercises by hand type of deal. I'll come up with something here out of 5 for you. But y'all decide and let me know by email or whatever how you want to handle whether we have a second test on 4 and 5 chapters out of the book, or do we make 4 and 5 along with the other material, make that into the final? And as I say, then that maybe will reduce y'all's stress level or whatever a little bit. But y'all just keep doing the fine job y'all are doing. I expect everybody to come out real good on grades. You already are. A couple of y'all have had to realize you didn't send homework in, or even one person on test 2 somehow didn't realize they sent me the test but not the answers. So you still owe me something. Get it to me. And but otherwise, have a great week. Call me if you need me. Email me otherwise. And as I say, if you're on campus Friday and somebody asks you about the program or about yourself a little bit, uh, you know, hopefully tell them what a great experience you've had. So we will see y'all soon.